Mastering Safety Interlock Systems. Cutting risks and costs begins with interlocking safety. Which primary objectives are we seeking to achieve by implementing a safety interlock system in our facility to ensure operational excellence and minimize risks? To achieve operational excellence and minimize risks, a safety interlock system, SIS, must be designed and implemented to meet specific primary objectives. The primary objectives of a SIS are to prevent accidents, injuries, and fatalities, and to ensure the integrity of the process and equipment. First and foremost, a SIS should prevent unauthorized access to hazardous areas, such as areas with moving machinery, high-voltage electrical equipment, or areas with hazardous materials. This is achieved through the use of interlocked gates, doors, and barriers that prevent entry into these areas until the hazardous conditions have been eliminated or minimized. For example, an interlocked gate may prevent access to a machine until it has come to a complete stop and all moving parts have ceased. Secondly, a SIS should ensure that equipment is operated within predefined safety parameters. This can be achieved through the use of sensors and safety-rated controls that monitor the equipment's operating conditions and prevent operation outside of the safe operating range. For instance, a temperature sensor may prevent a furnace from operating if the temperature exceeds a predetermined level, thereby preventing a catastrophic failure. Thirdly, a SIS should provide redundant safety functions to ensure that even if one safety function fails, others will still prevent accidents. This can be achieved through the use of redundant sensors, safety-rated controllers, and backup power supplies. For example, a safety-rated controller may monitor the level of a toxic substance in a tank and shut off the pumps if the level exceeds a predetermined level. If the primary controller fails, a redundant controller will take over and ensure the pumps are shut off. Fourthly, a SIS should be designed to minimize the risk of common mode failures, where a single failure could disable multiple safety functions. This can be achieved through the use of diverse safety functions, such as using different types of sensors or safety-rated controllers from different manufacturers. For example, a safety system may use both pressure sensors and flow sensors to detect an overpressure condition in a pipeline. If one sensor fails, the other will still detect the condition and shut off the pipeline. Fifthly, a SIS should provide real-time monitoring and alarm systems to alert operators and maintenance personnel of potential safety issues. This can be achieved through the use of human-machine interfaces, HMIs, supervisory control and data acquisition, SCADA, systems, and alarm management systems. For example, an HMI may display the status of safety-critical equipment and provide real-time alarms and alerts if a safety function is triggered. Sixthly, a SIS should be designed to facilitate easy maintenance and testing to ensure that safety functions are operational and effective. This can be achieved through the use of maintenance-friendly designs, such as removable sensor and actuator assemblies, and standardized testing procedures. For example, a safety system may be designed with removable sensor assemblies that can be easily replaced or calibrated without shutting down the entire process. Lastly, a SIS should be designed to comply with relevant industry standards and regulations, such as IEC 61508, IEC 61511, and OSHA regulations. This ensures that the SIS meets the required safety integrity levels, SILs, and that operators and maintenance personnel are trained to operate and maintain the system. In conclusion, a safety interlock system is a critical component of operational excellence and risk minimization in industrial facilities. By preventing unauthorized access to hazardous areas, ensuring equipment operation within predefined safety parameters, providing redundant safety functions, minimizing common mode failures, providing real-time monitoring and alarm systems, facilitating easy maintenance and testing, and complying with industry standards and regulations, a SIS can significantly reduce the risk of accidents, injuries, and fatalities, and ensure the integrity of the process and equipment. The pursuit of operational excellence in high-hazard industries, it's a daunting task, to say the least. I've had the privilege of working with organizations that have faced immense pressure to prioritize safety without compromising efficiency. One such organization was a leading manufacturing plant that had implemented a Safety Interlock System, SIS, to minimize risks and ensure operational excellence. As I delved deeper into their journey, I realized that their story was one of resilience, moral fortitude, and creative problem-solving. The manufacturing plant, a behemoth of steel and machinery, was a potential powder keg waiting to explode. The stakes were high, with the lives of hundreds of workers hanging in the balance. The management knew that they had to act fast to prevent a catastrophe. That's when they decided to implement a SES, a complex network of sensors, alarms, and safety protocols designed to prevent accidents. As I walked through the plant, I saw rows of machinery humming along, with workers moving with precision and purpose. But beneath the surface, I sensed a palpable unease. The weight of responsibility was crushing, and the management knew that one misstep could have disastrous consequences. The first hurdle they faced was the moral dilemma of balancing safety with productivity. How could they ensure that their workers were safe without compromising efficiency? It was a delicate dance, where one misstep could spell disaster. The management had to confront their own moral ambiguity, questioning whether the pursuit of profit was worth the risk of human life. I recall a conversation with the plant manager, a gruff, no-nonsense individual who had seen it all. We knew we had to act, but we were torn between our duty to our workers and the pressure to meet production targets, he confessed. It was a moral crisis, and we had to find a way to reconcile our values with our business goals. The breakthrough came when they realized that safety wasn't a compromise, but a prerequisite for operational excellence. By prioritizing safety, they could, in fact, increase productivity and reduce costs in the long run. It was a eureka moment, one that required a fundamental shift in their mindset. The next challenge was more tangible: how to design a SIS that would be effective, efficient, and easy to maintain. This is where creativity came into play. The team had to think outside the box, combining existing technologies with innovative solutions to create a bespoke system that would meet their unique needs. One of the engineers, a quiet, unassuming genius, had a brainwave. Why not use AI-powered sensors to detect anomalies in real time, allowing for swift intervention? It was a bold idea, one that required collaboration with AI experts, but it paid off. The system became a benchmark for the industry, a testament to the power of creative problem-solving. As I watched the plant's transformation, I felt a sense of awe at the human spirit. It was a story of resilience, of perseverance in the face of uncertainty. The management had confronted their fears, and in doing so, had created something truly remarkable. In the end, the SS became an integral part of the plant's DNA, a symbol of their commitment to operational excellence. The workers moved with confidence, knowing that their safety was paramount. The management had faced their moral ambiguity and emerged stronger, more united than ever. As I left the plant, I couldn't help but feel a sense of pride. It was a reminder that, even in the darkest of times, humanity can rise to the challenge. Operational excellence is not just about systems and processes, it's about the people, the values, and the courage to do what's right. Practical steps. 1. Confront moral ambiguity. Acknowledge the moral dilemmas that come with operational excellence, and be willing to reconcile values with business goals. 2. Rethink safety as a prerequisite. Prioritize safety as a fundamental aspect of operational excellence, rather than a compromise. 3. Embrace creative problem-solving. Encourage innovative thinking and collaboration to develop bespoke solutions that meet unique needs. 4. Leverage technology. Utilize AI-powered sensors and other technologies to enhance safety and efficiency. 5. Embed a culture of resilience. Foster a culture that acknowledges uncertainty and encourages perseverance in the face of adversity. What I thought throughout this process was that operational excellence is not just about systems and processes. It's about the people, the values, and the courage to do what's right. It's a testament to the human spirit, and a reminder that, even in the darkest of times, humanity can rise to the challenge.